All right, Math 2 7.2, special right triangles. And today we're talking about 45, 45, 90 triangles. So the 45, 45, 90 is talking about a right triangle with these two angles congruent. And if those are congruent, then it has to be 45 degrees on both of those. In a 45, 45, 90 triangle, the legs are equal. So here's a leg, and here's our hypotenuse. We could say, well, if the legs are equal, they are, what do we want to call them? We'll call them x, maybe. X, x. And if, say, we're trying to find our hypotenuse, we'll call it y for now. Well, if we were to use the Pythagorean theorem, we'd say, well, x squared plus x squared equals y squared, right? The legs and the hypotenuse. If we were to combine this up, we'd say, what would we say? We'd say, well, 2x squared equals y squared. And say we're trying to solve for our legs. Well, then x squared would be y squared over 2. So x is y over root 2, right? I took my root there. So to put that back into words, we said that the leg is equal to the hypotenuse over root 2. And that's going to be useful for us. So we're going to use that idea here. Oops. So we have the leg is the hypotenuse over root 2, and you could say the reverse of that, the hypotenuse is the leg times root 2. All right, this here is the big idea of today's lesson. So we're saying that in a 45, 45, 90 triangle, the leg equals the hypotenuse divided by root 2, and the hypotenuse equals the leg times root 2. So it's kind of a shortcut to the Pythagorean theorem. And I showed you this green stuff over here just to show you why these formulas work. All right. Okay, so let's look at number 2. Number 2, we have a 45, 45, 90 triangle because here's our right angle, here's a 45-degree angle, and this one also has to be 45 because 180 minus 90 minus 45 is 45, right? 180 degrees in a triangle. Here's our hypotenuse. Here are our two legs. We know that our legs are going to be equal because in a 45, 45, 90 triangle, the legs are equal. So y is going to be 6. And our hypotenuse, x, is going to be 6 root 2, right? I use the formula that the hypotenuse equals the leg times root 2. This is the formula that I use to get that right there. All right, and we're done. All right, number 3. Here's an angle. Here's another angle. It's a 45, 45, 90 triangle. B is a leg. Here, I'll leg, hypotenuse. So B has to also be equal to root 5 over 5. The hypotenuse is equal to the leg times root 2. So A is equal to root 5 over 5 times root 2, which is going to be root 10 over 5. So A is root 10 over 5. There we are. All right, number 4. Again, we've got, here's our hypotenuse, here's our two legs. V is a leg, so it's just going to be equal to the other leg, so 3 root 2. Now U is the hypotenuse, so it's going to be 3 root 2 times root 2, right? Here's our leg times root 2. Well, root 2 times root 2 is plain old 2, so we have 3 times 2, which is 6. So u equals 6. All right. Number 5. This should be pretty quick by now. The leg, hypotenuse. So V, is this the same problem? No, it's just a little bit different. V, I'll change my colors here. V is equal to 2, because our two legs are equal. U is going to be 2 root 2, right? It's the leg times root 2. All right. You'll notice that everything so far, we have been given the leg, and we've had to find the hypotenuse. Whenever we have the hypotenuse, it's going to be just a little bit different, and you'll have to do a little bit of rationalizing, but we'll get to that in number 7. Number 6, leg, hypotenuse. So y is going to be 7 root 2 over 2. X is going to be 7 root 2 over 2 times root 2, right? Here's our leg times root 2. This root 2 and this root 2 make a plain old 2, so it's going to be 7 times 2 over 2. My 2's cancel, and I'm left with 7. So I could say, well, x equals 7. All right. Number 7. This one's going to be a little bit different because here's our leg, and our hypotenuse. This time our hypotenuse is given. So our legs we know are going to be equal. So really we only have to do one thing again. We're just going to find x or y. I'm going to find x because that's the variable I'm used to. We remember that one of our formulas is the leg equals the hypotenuse over root 2, right? So that is going to be 8 over root 2. Now, a lot of the time, we don't like to have roots in the denominator. So we need to change 8 over root 2 to where there's not a root in the denominator. The way that we do that is we multiply by root 2 over root 2. These bottom root 2's give me a plain old 2. And the numerator gives me 8 root 2. Now I can cancel the 8 and the 2, and it gives me 4 root 2. So x equals y equals 4 root 2. All right. Number 8, back to an easy problem. Y is going to be 9, because here's our leg, hypotenuse. And our x is going to be 9 root 2. All right. And lastly, number 9. B is another leg. It's going to be 3 root 2 over 2, right? Because these are leg, hypotenuse. A is going to be 3 root 2 over 2 times root 2. Our root 2's turn into a plain old 2. The 2's cancel, and I'm left with a 3. So A equals 3. All right. Pay special attention to problems like number 7. I know that there was only one problem like this, but we need to pay special attention to it. The hypotenuse was given, so we need to make sure that we use the formula that says leg equals. Right. Alrighty, that's it.